Now we will look at what is a division. So division is one of the four basic operations in mathematics. The division is all about splitting numbers into equal parts. So when you want to split numbers, that means you have to use a division, and it has a notation such that you will see if we have a variable, it can be a divided by b, or sometimes it is written as a over b or a over b. So those represent the notation of a division. And if we have a divided by b is equivalent to c, this a is called the dividend. This term is the divisor, and the result is the quotient. And in division we have a number which can be a remainder. Therefore, when we have c, when the divisor is not completely divisible with the dividend, it produces a remainder. We will look at some example so that you can be able to understand how the division works and how the remainder can be produced from this process. And we can now talk about the properties of the division. That means every operation, the division process will have this property. The first one is the non-commutative. We talked about commutative in our previous example when we discussed addition, subtraction, multiplication. And in division, it is non-commutative. That means a divided by b is not equals to b divided by a. That means the variable that appears along with the operator is important. Variable may have different values, so in order for them to appear with the operator is important. Therefore, it is a non-commutative, meaning the structure or the arrangement in which they appear before or after the operator sign is important. Example, if a is equals to 8 and b is equals to 2, then we have 8 divided by 2 is equals to 4, and 2 divided by 8 is equals to 1 on 4. Therefore, we can say 4 is not equals to 1 on 4. The second property, it is non-associative. It means division does not follow associative property, which means that a divided by b divided by c is not equal to a divided by b divided by c. Because it is a non-commutative, it is also non-associative. They share the same property as the multiplication. 3. It has identity property. Identity property meaning if it is divided by 1, the answer will be equals to the variable itself. In case where we have a divided by 1, it is still equivalent to 8. So these are known as the identity. So any variable having a value which is divided by 1 or having the divisor of 1 will still gives you the value of the dividend. So the dividend is a variable which produces a quotient, which is the dividend itself. When divided by 1, it will still gives us the same result. And we have 4, which is the zero property. So zero property, what does that mean? 0 divided by any non-zero number is 0, or 0 divided by any variable having a number is equals to 0. This is shown as 0 divided by any number will still gives you a 0. This is one of the property of a division. So we can see that the dividend cannot be 0. When we have dividend is equals to 0 divided by any variable, which will still gives us 0. And 5 divide by itself will gives us 1. Any variable divided by itself will be equals to 1. That means the dividend and the divisor, if they are divided by themselves, they will always give 1. We can also identify that multiplication and division, they are opposite to each other. The inverse of multiplication is the division. The inverse of division is the multiplication. 6, we can say division by 0. What does division by 0 means? It means any variable divided by 0 is equals to the quotient unidentified. Therefore, any divisor which is equals to 0 with any dividend which is a variable will give us a result which is undefined. In many real-life applications, you can see that we use maths to solve problems. Therefore, I will give you some example of the application of division. Example 1. So we said splitting number into equal parts. Imagine you have 20 apples and you have 4 friends. You want to give the 20 apple to 4 of your friends. So you want them to have equal number of apples. Therefore, you said 20 apples with your 4 friends. So you will have the quotient which is 5. This number of 5 represents the number of apples that can be given each to your friend. Now your friends will receive 5 apples each. Another example is to do with the calculation of the rate. You want to find the rate, for example, speed. Speed is equals to the distance divided by time. By looking at the speed, it is very important. If you are traveling on a vehicle from point A and you want to reach point B and the distance is 1000 miles. Then if you travel from point A to point B and the time it takes is 1 hour. Now you will know the speed in which you travel. Now you can just compute by knowing the distance 1000 miles divided by 1 hour. You will have 1000 miles per hour. And you can also find the distance in which you covered per minute. We all know that the time 1 hour is equivalent to 60 minutes. And if you want to find the speed per minute, you can simply speed in minutes is equivalent to 1000 miles per 60 minutes. We can cross the 0 and 6 into 100. You will have 16.6667 miles per minute. That means every 1 minute you covered 16.6667 miles. Now, by looking at this, the 16 represent the quotient and 6667 represent the remainder. It is important for you to understand the speed and the time it takes to cover distance. And as I have mentioned, if you know the speed and you know the time it takes, example 1 minute, and someone was asking you if you travel half a distance, it will be 500 miles. And the 500 miles is equivalent to 30 minutes in order to get these 500 miles. And if you are traveling at the speed of 16.667 miles per minute, then you can calculate the speed times the time to give you the distance. So if someone asks you how long did you travel from alpha distance between point A and point B, then you have speed which is 16.6667 miles per minute times the time is 30 minutes. We can have 500.001 miles. Therefore, it is equivalent to 500 miles. So you can transpose the formula in order to find out the value or the variable in which you want to find. So in this example, we have time, distance, and the speed. So you can compute all these variables if you know two of them. Then it is easy to find the unknown, which can be one of them. If questions are given, so long as you have the two quantities available in order to find the one quantity that is of a question. In our future problem solving, you will be able to find out that we use those basic operation, addition, subtraction, multiplication, and division all throughout. The basic form in which you need to understand and appreciate is the basic. Once you know the basic, you can be in a better position to compute and solve the problem. We mentioned previously that mathematics is used to solve problems. So there will be more and more real life problems that we represent using a variable, and those variables are designed to have a portion of a number. And by using mathematics, you can relatively solve most of them. Now I will give you a brief summary of the basic operation, the addition, the subtraction, the multiplication, and division in electrical engineering. So you will mostly come across those operations when you are dealing with basic electrical knowledge. One, the addition. I can only give you one example in series resistor. We have three resistors which is connected in an electric circuit. We have the voltage source and the ground. You have R1, R2, R3, and this is 100 ohms, this is 50 ohms, this is 30 ohms. Therefore, you will be given a question to calculate the total resistance of this particular circuit. Therefore, we use the arithmetic, which is the addition. We can say the R total is equals to R1 plus R2 plus R3. If many of the resistors are connected in series, therefore we normally add. So the resistor total will be equals to 100 ohms plus 50 ohms plus 30 ohms, which will now have 150, 180 ohms, which is the total resistance in this particular electric circuit. And two, we look at the subtraction. In subtraction, we can deal with error correction. I have made mention previously, if we have the V in and we have the V out, which normally gives the error signal in a control system. The formula for such equation will be equals to error is equals to V in minus the V out. Imagine if we have the input voltage, which is 5 volts, and the output voltage measure is 5.2. Now the error that is produced in such system is equivalent to 5 minus 5.2. Now we can have minus 0.2 volts, which is now the error signal that needs to be computed in order to have V in is equivalent to the V out for the system stability. In that case, there is no stability because we have a minus 0.2 volts, which is the error. So you can be able to see that addition, subtraction are also present in electrical engineering and the system. So the subtraction is performed in a control system, and the addition can be applied to the Kirchhoff current law, Kirchhoff voltage law, or adding a series resistor connected in an electrical circuit. Thirdly, we now have multiplication. Multiplication in example of power calculation. In power calculation, we know that power is equals to the voltage times the current. Imagine if we have a circuit with a voltage source connected to a load resistor, and we have the current of 3 amps and a voltage of 5 volts. To compute the total power that is absorbed by this particular circuit, we can now compute power equals to 5 volts times the 3 amps, which will gives us 15 watt or 15, and this total power is now consumed by which of the electrical component. This power is now dissipated by the load. So when we talk about total power used in a circuit, this particular load use this energy. And similarly, if we have a system having input and the output, now if we have the system gain as 5 and we have the input signal which is connected to the system, and if this input have 10 volts as an example, we all know that the output is now equals to the gain of the system times the voltage input. If we have the gain of 5 and the input voltage is 10 volts, we all know that the output voltage is 50 volts. So this represents the multiplication, and this is also used mostly in circuit and many areas in the field of electrical engineering. So these are some of the applications that shows you that it is important for you to learn mathematics, because those mathematics are now going to represent the entire system. Finally, we will look at division and why division is important in electrical engineering. We want to achieve stability in a system. We have the output and input to a system. Example, this system represents a conductor. And this conductor, we want the conductor to have the loss which must be very less. When we say very less, that means it has less resistance. When we talk about zero resistance, that means there won't be any loss within a system. Imagine if we have 240 volts AC and the output is 239 volts AC. By comparing these two values, V in and V out, we all know that 1 volts AC is missing from the output. From a perfect system, we want 240 volts must be from the input, and we want to achieve the output having 240 volts AC. But in real life, there are no perfect system. We always prone to having losses at the output of any system. Then the best way to find out the type of losses, we normally use efficiency. And the efficiency is calculated using the division, the V out divided by the V in. For our case, the output is 239 voltage AC and the input is 240 volts AC. So what is the efficiency of this system? Our result will be 0.9958333. This is now the efficiency of the system. When we want to find the percentage efficiency, then we normally multiply the efficiency times 100%. Therefore, we have 0.9958333 times 100%, which will give us 99.58%. This is the efficiency of the system, and we normally have a small percentage loss. If we have the input 240 volts AC and the output we have 200 volts AC, how can we compare this efficiency? Therefore, efficiency is equals to 200 divided by 240. Then we can multiply by 100 to check the efficiency in percentage. Now we have 0.8333 times 100%, which will now give us 83.33%. So we can compare this with this value. We can see that when this value of the output continue to decrease, we will have the efficiency which will also goes down. Therefore, we can say that when the efficiency drop, that means the system is unstable or it is not a perfect system. Therefore, as a designer, you have to redesign the circuit to achieve the input must be equal to the output. And now this can be a perfect system. So by the end, you can appreciate that those basic operations of arithmetic is mostly found in real life application. And I know you will appreciate learning all these operations in arithmetic.